Now, one limiting factor that inhibits widespread acceptance of 100% electric vehicles is that the lifetime of the battery is not as long as the time you get to drive on a full tank of gas. To increase the amount of charge in the battery during driving, the motor can act as a generator whenever the car is braking, taking advantage of the back EMF produced. This extra EMF can be newly acquired stored energy in the car's battery, prolonging the life of the battery. This implies that electric and hybrid vehicles also take advantage of electromagnetic induction. This has its roots in Faraday's law of magnetic induction, which are as follows. The first law states that whenever a conductor is placed in a varying magnetic field, electromotive force EMF induces, and this EMF is called an induced EMF. And if the conductor is a closed circuit, then the induced current flows through it. The second law states that the magnitude of the induced EMF is equal to the rate of change of flux linkages. Based on his experiments, we now have Faraday's law of electromagnetic induction, according to which the amount of voltage induced in a coil is proportional to the number of turns and the changing magnetic field of the coil. So, the induced voltage is as follows. E equals N multiplied by d phi dt, where E is the induced voltage, N is the number of turns in the coil, phi is the magnetic flux, and T is the time. In this lesson, we have learnt about Faraday's law of magnetic induction. In the next, we will move a step further to examine Lenz's law of electromagnetic induction. I'll see you there. Bye for now.